Good evening, boa tarde, as good afternoon to our Brazilian visitors and attendants. I'd like to welcome you to the webinar by the KNVTS, the Royal Dutch Association of Engineers in the Maritime Industry. My name is Eric Schiphorst. As a board member of the KNVTS Amsterdam branch, I am honored to host this webinar tonight, and I'd like to thank our team for the great preparations to make this work. We have been hosting webinars every month and will do so for the next couple of months at least on a range of maritime technological topics. If you want to keep informed about it, do subscribe to our mailing list or become a member of the KNVTS. This webinar will be about 15 minutes, maybe a little longer, with the presentation being 30 to 35 minutes, and then there will be time for questions. Do know that probably not all questions will be answered. There's just not enough time, but we will have later on a post on LinkedIn with an overview of all questions and answers. And of course, later on, there's always a way, we can always provide ways to stay in touch with our lecturer of tonight. The person talking tonight about our unmanned surface vehicles is Mr. Rafael Coelho, Naval Architect, Chartered Engineer, and one of the founders of a Brazil-based company, TideWise, and responsible for the company's product development, engineering, and design. As he told me, since the age of 3, Rafael considers himself as a sailor, and since then always been on board a range of vessels and ships, which is kind of funny in the light of the focus of your professional career. Over the past 8 years, being in the forefront of removing people from boats. After some years in design of yachts and small crafts, you have been involved in the development of USVs as of 2012, first in UK, then Brazil, and as of 2019 from TideWise. Please, it's up to you. Enjoy.
Thank you very much, Eric. Thank you very much for the introduction, and thank you, KNVTS, for the invitation. Well, it's a pleasure to be here tonight. It's afternoon in Brazil yet. It's beautiful blue sky and warm here. So, well, I'll talk a little bit tonight about the development of unmanned surface vehicles. Generally, a brief introduction of what they are and what they do and where it's going. As Eric said, I'm director of TideWise, co-founder of TideWise. We are a Brazilian startup that provides unmanned marine service in Brazil initially, aiming to go bigger and abroad in the next couple of years. So my background, I'm a naval architect, as Eric said, and my relationship with the Netherlands actually started in 2008. Just as soon as I graduated, I competed on the Frisian Solar Challenge. That's a competition of solar boats that runs the Frisian state in the north of Netherlands. And it was an amazing experience to build a boat in Brazil and take it to Netherlands. I think we were the first South American team competing there, and we had a very nice competition, and we created a lot of friends. And since then, I've been involved in the Dutch maritime industry somehow, either with suppliers or with clients. Last year, we had a very nice client from Netherlands, and we have been doing some works with them still. And it's a big pleasure to work with the Dutch maritime industry. So unmanned surface vehicles nowadays are also known as MAS, maritime autonomous surface ships, and this nomenclature, it came from the IMO, from the Marine Safety Committee. I think back in 2019 or 18, they start to use this new nomenclature, and the industry is slowly adopting that. But if you're going to study about the topic, I strongly recommend to search for unmanned surface vehicles. Right. So how do they look like? We can separate USVs for their size or weight, mostly size. If you use the guidelines of the industry or the first rules of the classification society that are being developed right now, the separating according to the vessel length, and the first threshold is 7 meters. So vessels under 7 meters are considered ultralight, and normally they operate at low speed. But when you get fast speed, and then is a relationship of the length, so it's a fruit number of the vessel, and then is a different topic. But if you consider just displacement boats, you can sort by length only. So there are hundreds of them operating in the world. They are manufactured in Europe, in the US, in Brazil, in China, in Australia. So there are manufacturers everywhere in the globe, and they tend to be very local applied. The vessels are very specific design and construct. So you have small USVs for bathymetry, small USVs for water monitoring. In TideWise, we decide to go a little bit different. So our USV is very multi-purpose. So we can configure the vessel in different ways, allowing it to do different jobs. After the 7 meters, the next threshold is 12 meters to meet what's the standard in the industry. Then you have dozens of those boats being operational in the world, mostly in Europe, some of them in US and China. They normally use for bathymetry work, survey, or some support of offshore operations. The next one is 12 to 24 meters. They are considered small. Most of the military vessels goes into this category. They're normally very fast and designed to do jobs for military applications as mine countermeasuring, missile targeting, surveillance, and other other naval applications. And the last one way of separating those vessels is above 24 meters. There are a few prototypes operating in the world. There are dozens of those vessels being built right now. One company announced start the construction of a 70-80 meter ship to be hybrid, so it can be manned or unmanned. And that's kind of what happens on this kind of size of ships. The regulations are not there yet. That's the big challenge in this size of vessel. And there is expected to have a new regulations 2023 to allow those vessels to operate with less people involved. So a normal question I receive is how smart USVs are. So are they totally unmanned? Are they totally autonomous? Or are they just big remote control boats? So how smart they are? And that's a difficult question. And the best way the industry converged to answer this question was to create 4 levels of autonomy. So the 4 degrees of autonomy that's accepted by IMO, and also that's a derivation from the guidelines that were developed in the UK from the Maritime UK Industry Council, and the whole industry got together and worked since 2016 on a guideline that is issued every year in November. We just had the last one in November 2020, and this guideline is kind of considered the Bible of the industry. So from there, you have all the codes being generated. And I think it'll be like that until 2023, when IMO actually start acting as the main authority in the topic. So the first level of autonomy will be a normal vessel. So people are on board, but there are some functions that are made by computers. So that's what you have on a modern workboat, for example, where you have autopilot or automatic bilge pumps and things like that. And the second level will be remote control ships or vessels. So the vessel is controlled from another place, but you still have people on board. And that's a kind of hybrid configuration where some of the tasks can be done remotely, but you still have people on board in case you need. The third level is the level that most USVs are operating nowadays. So the ship is controlled and operated from another location. That can be a mothership or can be a shore base or control station. And there are no one on board, unless they are considered as payload, for example, divers for a naval mission. And that's where we are at TideWise, and that's where mostly of the industry is operating. The fourth level is where everyone is aiming to be. That's fully autonomous ships. So to be a ship that can sense the environment around it, it can choose the best way to follow. It can understand if something is not working as it should be, and now that's a new topic. It can protect ourselves from cyber attacks. So that's where the industry is aiming to be. I think we still have 3 or 5 years to be there. At the moment, the third level is enough to operate commercially, to generate revenue, and to grow this market at a very fast rate as it is growing nowadays. The forecast for 2030 is to have a market value of $135 billion. So that's a very fast growth rate for the maritime industry. Just an example of our USV, Tupan is our first class of USV at TideWise. She's a 5-meter USV, touch before 5 meters. That's because of regulations in Brazil. So if you're operating under 24 meters, you need to follow the flag states regulations. And in Brazil, we have a special regulation that limited crafts in 5 meters makes everything simpler. So that's why she's 4.92. Displays just above 1.2 tons. So although they're small, they're quite heavy for this kind of for this length. I believe there are some naval architects attending to the webinar, and you can notice that they are heavy for the size. Tupan is diesel electric. One of the solutions we found was to use twin props, fixed pitch, direct drive. So we have a fixed pitch prop with a direct drive line and a motor, electrical motor, and that's powered by a battery bank that's charged by a diesel generator. This kind of operation provides more endurance at low speeds missions, or when speeds that you need to, or missions that you need to fluctuate the speed a lot. It provides more redundancy in terms of control and precise control as well. The use of electrical motors are much easier to control than direct drives on diesels, especially when you have a computer controlling the props. She's designed to have endurance of 7 days. So at low speed, if you're doing tracking or monitoring missions, we can operate for a long time. a vessel of this size, if it was manned, you'll probably have endurance of 8 or 7 hours due to the man limitation. And we can control TUPAN up to 18 kilometers using radio links, or we can use the 4G, the mobile network, or we can also use SATCOM to operate over the horizon. That's one of the big differentiations on the communication side of USVs. So line of sight is one kind of one mode of operation, and if you go above the horizon, you need SATCOMs, and you need to have a lot more autonomy built into the vessel to operate on a high latency link. So that's a kind of the two big difference in communications. So what for? I think everyone that had a water damage mobile phone knows that electronics and water doesn't go along very well. And in USVs is exactly the same case. We are always trying to make the system robust, watertight, and able to operate in a very harsh environment as the sea. So especially in Brazil, we have another challenge, that's the heat. So when you make everything very watertight, you have problems dissipating heat. And that's a kind of good example of the trade-offs you need to do in design of USVs that are not very common in bigger ships. If you have a boat that's 5 or 6 meters long, you probably won't have as many electronics or power being consumed, electrical power being consumed on board. And if you are consuming the same amount of power, is in a much bigger vessel when you have much more capacity to cool down the electronics. So that's just one example of the challenge we have in this industry. There are other challenges, for example, how much work should be done by software, how simple it needs to be the hardware to be reliable, or the level or quantity of control and monitoring components to make everything more reliable. It can actually cause it to be less reliable because I have more point of failure. So that's all specifics of the industry that we learned over these last 8 years to choose what to do in each condition. So TUPAN, for example, we use for bathymetry, so survey work. That's a very hot topic right now in Brazil, and I believe most of these vessels up to 12 meters are, if not dedicated for survey, they can all do survey very well. Some of them were designed specifically to do survey, designed to have very low pitch movements and roll movements to improve the quality of the data that's being collected. That was the case of a USV I designed for when I was in the UK for a Dutch company that's very famous to do survey. So that's one of the nice parts of designing USVs. You start from a blank page with a long list of requirements, and there is a lot of freedom to what you're gonna do. TUPAN, we solve the issue of motions in a completely different way. For example, we have active roll and pitch compensation, and therefore we have a multi-purpose USV that can collect very good survey data without limiting the vessel to other applications. That's a kind of what happens in a very early industry where you can the generation of vessels evolve very fast. Another application we have is surveillance and monitoring of assets. These images illustrating the monitoring of a buoy of a channel. That's one of the topics we are exploring in Brazil. There are a lot of new harbors being built, and the law is changing in Brazil. So now we can the companies can explore more these markets. Before it was all due to the Navy. Another application that I want to illustrate is oil spill monitoring. That's a project we just completed in December with Repsol Sinopec, is a big oil company that's exploring oil in Brazil. and we did the integration of a drone with our USV to identify oil in the water. It's a quick movie, but I think it explains well what has been done. That's showing the Dupa navigating to the position. You can briefly see the stable landing pad keeping level with the horizon. We developed the autonomous takeoff and landing in partnership with the local university. The system can also be integrated with a feather if you want to fly the drone for longer periods to do surveillance, for example. So that's a very short movie, and we're gonna publish the long version where there are a lot more details of the project and the technology in the next couple of weeks on LinkedIn. So if you want to know more about that, just keep following us on LinkedIn, and there'll be more news there. So in general, not just on TideWise, but in any USV operator company, the missions or the jobs are based in 4 pillars. So we collect more data than conventional vessels. The data we collect has more value because the quality is higher, is more repeatable, and you can be in the same position for longer periods. So therefore, you can collect a larger amount of data in the same position for a longer period of time. So you increase your time and restoration. We have less risks. That's one of the biggest drivers right now to the adoption of the technology. And you also reduce the environmental impact. When you remove the man from the vessel, you remove systems, you remove weight, remove power, and therefore you burn less fuel. So those are the 4 big drivers to use USVs. In Brazil, we separated the market in 3. So we have harbors, that would be protect waters, coastal and offshore. Brazil has a big boom of harbors now. There are a lot of new harbors being built or improved. The country depends a lot on trucks, and the government is trying to change that and increase the number of ships transporting cargoes between the country harbors. So to do that, they need a lot of dredging, and if you need dredging, you need a survey, and they also need surveillance. Security in Brazil in some areas can be quite complex, and therefore the use of unmanned system to do surveillance is very attractive. And we also develop in TideWise a technology to do draft max reading remotely. I believe that's a first off in the world. We have our own artificial intelligence software that can identify the draft marks on a ship and tell the operator what's the draft of that ship. That's normally done on a small vessel, manned vessel, and this operation brings in a lot of risk. For coast operations, we do also surveillance. There is a new market starting for aquaculture, that will be fish farms. In Europe and US and Australia, these markets a little bit better developed, but is starting in Brazil as well. Mammals monitoring is another topic. We have a very hot offshore industry in Brazil, and one of the topics is one of the challenges to keep mammals away or to stop the drilling operation or the seismic work when we notice that there are mammals in the area. Environmental monitoring is also an important market for coast operations, and also cargo transport, as I said before. For the offshore industry, Brazil has the largest FPSO fleet in the world. There are, I think, 19 or 20 more coming in the next 5 years or 10 years, and this number is growing. I think the whole world is changing the energy matrix, but in Brazil, I believe that to happen a little bit further down the line. So there is a lot of work to do in UI surveillance. So that's the surveillance or the survey of the hull of FPSOs without the need of taking the ship to a yard. So that's normally done at the position the ship is operating during the lifespan. And nowadays it's done with offshore support vessel with ROV. So now what we are trying to achieve in Brazil is to do that with USV, a TideWise USV connect to ROV to perform this work. Oil spill monitoring is, as I said before, and I show on the video, is very important in Brazil. The use of USVs in this kind of application reduce the risk, reduce the costs, and improve the windows, the weather window where you can do monitoring. Metocean data collection is very important. Now with the growth of the wind farms, that's very important data to have to identify where is a good site to install farms and what are the challenges to do this work of installation. Cargo transport offshore is also a hot topic. And as I said, yeah, USV plus ROV for subsea inspection, not just in Brazil, but everywhere is being seen as a very advantageous mission to do with USVs. In terms of regulations, up to 24 meters, you don't need to comply totally with SOLAS, and therefore you can just follow the flag state. That simplifies a lot the USVs, and the operations get cheaper, and sometimes it's better to have a higher number of smaller USVs than aiming for a larger USV where you're going to fall on the gray area of the regulations. The IMO, as I said, is planning to issue the first regulations 2023. The insurance companies now do cover USVs operations and the USVs themselves. That's a big milestone for the industry. And the man in the loop is the most common operational concept we have right now. So although the level of autonomy is high and the vessels can identify hazards and targets or other ships in the area or other boats that they need to avoid collision, we always keep the man in the loop to perform operations. A bit of our way of designing TideWise, so the TideWise design process, and I think most of it came from the experience of design multiple USVs in the last 8 years. USVs are completely different from, well, not completely different, but very different from all the vessels, especially under 24 meters. If you go above 24 meters, they tend to look very likely other ships. But for small USVs, you're always trying to have as cheap as, well, as cost effective as possible and as small as possible, and increase the amount of work this USV could do. So during this time, we identified that the normal ship spiral process is not a very good approach for us, or not a good methodology. And I believe back in 2014 or 15 in the UK, I worked with the design council there, and I ended up learning the double diamond process or methodology, and that's normally used by product designers to develop and deliver very quickly new products completely out of blank. And that we adapted a little bit for vessel design, for boat designing, and the process we have right now we are very happy with, and we can produce very quickly very reliable and effective USVs. So it always starts with the problem. So we spend a lot of time, a considerable amount of time, describing the problem with the clients. Sometimes the client is ourselves, so it's an internal project. But even when it's an internal project, we spend a lot of time describing what we want to achieve. And after that, we have a certain period of time where we are exploring the options. So we call it the discover part of the process, when the engineers and designers are exploring all the possible solutions that could potentially work. And at some point, we start to cross solutions that are not very good, or not potentially, or that has a low level of potential to work, or too much complexity, or for any other reason we discard those options. And that's where we call the define state. And at the end of this first cycle, we end up normally with the requirement matrix that's on an engineering level. So where we actually describe in numbers what the vessel should be able to do. And we already have a very broad idea of how the vessel looks like, or should look like, or potentially will look like. And we also define very well how it will be operated, because if you don't have a clear view of how the USV is going to be used and controlled and operated, it's very likely you're going to end up with a vessel that won't do what needs to do. So from this middle state or stage, we start the development phase, and that's closer to the spiral, the ship spiral, where you have a lot of small cycles of prototyping, testing, and refining a solution. And at some point, we start to converge again to a delivering state, where drawings are generated, and we finish a bill of material, and diagrams are generated, and you actually have a good description of the solution. I think that's very quickly the big difference between our design process and the conventional and traditional ship spiral process. So the design envelope we work with is compressed in between two spheres. So we have on one side the requirements, and on the outer side you have all the constraints that are normally environmental, financial, regulatory, or safety constraints. So we end up designing a solution that meets both spheres or both boundaries there. And at TideWise, we use agile development that comes from the software industry. Of course, the USV industry there is a lot of software development, and instead of have teams working in completely different methodology, the software and the hardware, we decide to teach or train the hardware team to work in the same methodology. Over here we have fixed squads, so a fixed team for each project. We use multidisciplinary, so different kind of skills for in the same squads. The sprints are very short, 2 weeks, and we use Kanban board to manage our tasks. So I believe that's a very good approach, and we developed the aerial project of the drone integration, and the USV used this methodology. We also designed Tupan using this methodology, and we achieved a lot in 1 year. That was actually a very hard year, 2020. We start from an empty shell hull and finish with a drone landing autonomous on a working USV. Another interesting way to describe our methodology is how we break down the challenge. So if you imagine the top of in the top you have the project deliverables, and we break down in smaller tasks until we have personal tasks in the end. So the project deliverables are breakdown in milestones that's agreed with the clients, and then for each milestone we have goals, and those goals are what we meet during the sprints. And then from the goals, each engineer or employee create your own task and manage your own task. So in the top you have clients and the management of the team, and the bottom you have personal task of the workers. That's it. That's a very short introduction of presentation of what we do at TideWise. Our aiming is to change the way we work at sea, and I believe we are successfully doing that here in Brazil, and soon, hopefully, we're going to be in the Netherlands.
Thank you, Rafael. Very clear and yeah, interesting presentation. Thank you very much. We've had some really interesting questions. So if you're ready for it, I'd like to shoot some of these to you.
Yeah, go ahead.
Yeah. To start off with, what will be, in your opinion, the main challenge for the maritime industry to adopt autonomous vessels? Is it regulations, maritime training, cybersecurity?
Yeah, I think the main challenge is regulations right now, and cybersecurity will become a problem as soon as we have more vessels operating. I don't think it's a problem right now, and some people say because you still don't have the cybersecurity problem, and cybersecurity evolve very fast. By that, it's too early to create too much fuss or too much protection right now, or too much regulation about cybersecurity, because by the time you finish the regulation, there'll be all the kind of attacks. That's my view, and some people have a different approach, especially people that develop the safety sides of the cybersecurity attacks. It's pretty much like the antivirus industry in the 90s, where they created virus to sell antivirus. It's not far from that. And now we have very stable systems operate. Everyone has a useful antivirus in your Windows, for example. That's maybe not the perfect comparison, but yeah, that's what I believe what we are passing through. So there'll be some work to be done in cybersecurity, but I think we're gonna go above it quickly. The level of cryptography that's being used is very high, and there are a lot of already used in other industry solutions that can be applied for the shipping industry. For example, airplanes, they are very safe in this aspect, and there is a lot of we can bring from this industry. There is people bring solutions from nuclear plants. There are solutions come from everywhere. So the solution, I believe they already exist. It's just a matter of adapting for USVs. I believe regulation is the big challenge, and the industry is doing very well at the moment because it's developed regulations globally. You have some specifics, small specifics for each country, but it's all involving from one document or one big group. I think that's a lot easier than what happened with the drones, that the development was very fast, and now it's very complex to operate. There are drones that you can fly in France, but you cannot fly in US, you cannot fly in Brazil, and it can get very complex. And I believe that was a lesson learned to our industry, and we are in a better shape than the drones ones.
Thank you. Thank you. Different question. What are the weather criteria that limitate the use in the offshore sector, in the maximum weather window that the system could work in?
Right. Yeah, that's a very common question. And USVs, they survive much harsh weather condition than traditional vessels. Because we don't have the people on board, we have a much lower center of gravity. most of the USVs that operate offshore, they are, well, the small ones, they either self-righting or very close to be self-righting. And so the weather condition that they can survive and keep away of other vessels of not becoming a hazard to the traffic. I believe it will be Sea State 7, 8. For 2 Sea State 7, we are fine. We can move around. We can keep away of other ships. But the quality of the data you can collect is very poor. So normally what will happen is you can collect the data, depend on what data you're collecting, but you can collect the data up to Sea State 4, and after that, yeah, you're just standing by, especially in survey. If you're doing, if you're collecting sound data, for example, with hydrophones, then you can operate on a higher sea state.
Okay. Thank you. We also got some questions in which have more relation to the system and the design. So one question here is to ask for your opinion, what you think which will be the most chosen source of power for autonomous vessels. And then especially, of course, in the range of the type of vessels and the size.
Right. Yeah, that's a good one. It depends a lot. It depends more on the mission profile, what you're trying to achieve, and what data you're trying to collect. Well, if it is data collection, because sometimes it can be just a cargo transport. I think that's what drives the power solution. For example, if you're collecting metocean data, then you need to be offshore for very long periods. You don't need too much. You don't need to move very fast, and what you want is to be there for a long period. And then wind and solar and waves are very good solutions. So you have a sailing boat, sailing USVs that are collecting metocean data everywhere. But if you're doing, for example, subsea work or offshore work, as we are doing in Brazil, where you need a lot of higher level of control, or you need to maneuver very precisely, you need to move in tight areas, and integrate with all the robots, either AUV or ROV or drone, then you need to have higher level control, and therefore you consume a lot more power. Then I think diesel electric is the best solution. I think what the diesel electric for me, if you're not doing like a long endurance, diesel electric is the best option. And then there's that size where it gets very complex to do diesel electric. If you're like 40 meters, 50 meters, it can get challenged with the current technology. But I think the ship industry is changing in this topic as well. So
yeah. Okay. Different question. Are you, as TideWise, developing your own autonomous navigation capabilities, or are you using third-party technology for that?
No, it's all our own technology. So we design the vessel and the software. We have a software team and a naval arch team, and it's all in-house. What we don't develop is, for example, data collection software, because that's is normally used by the industry, and normally our clients want to use a specific software to collect and treat the data, for example, for survey. So in this situation, we have like when it's down to the payload, we have partnerships with software companies that sell these products. Okay.
Yep. Thank you. We still have a little bit of time to answer a few more questions. Let me see. There was a question about the propulsion system. Oh, I can't find that one. Here it is. Question is the propulsion train of the Tupan fully redundant? Meaning from the from the fuel lines to the engines up to the propellers?
We have only one generator, so that's where our redundancy stops.
Okay.
So if we have a failure on the generator, we have a limited time of use. There is the option to use solar panels so that we can use the vessel in a limit or degraded mode, where we have less power available for the system.
Right.
So we're going to still have the battery bank as like a fallback power supply, but yeah, we only have one means of generating power. We can charge the batteries from the grid if you're operating in the harbor, and then we can use battery and shore power, depending on what kind of mission we're doing. The drive tank itself is completely redundant, so it's fully redundant, and we have rudders. So if one drivetrain fails for any reason, we can still navigating, and actually with quite good control.
Okay. And another question in line with that: for which type of problem or a type of mission was the TUPAN originally designed?
TUPAN was designed for bathymetry, so survey, and metocean. So if there's a lot of work here for monitoring currents, offshore currents, to identify if you need to stop the reading or not, for example, or pipe laying work. You need to know very well what's the condition of the current. Yep. So we can also do that. Environmental monitoring with the Ariel. Not exactly with the Ariel, it wasn't designed for Ariel, but we made the vessel in such a way it can be very flexible. Okay. But yeah, the main application would be harbor work, like draft marks and surveillance and survey. But
it wasn't just one launching customer that you.
No. We designed the boat for ourselves. We see ourselves as a service provide company. So we don't sell the USVs. We operate them for clients to collect better data in a better cost-effective way.
Okay, completely different question. How is the air intake and prevention of water ingress through air intake in serious sea states prevented?
It's complex. It's complex. What we have right now.
Also leave it for later.
Yeah, well, that one is easier to sketch something. Okay. But what we have is very similar to a safety one of the escape safety vessels that you have on ships. So you have a cross U-shaped pipe system that avoids water being collected.
Okay. Well, let's see if we can if you can make some sort of a sketch in your Q&A presentation.
I will try.
Do you have any procedures in place if a vessel goes rogue?
Yes. So there are different layers for this kind of problem. So the vessel itself has a dedicated, that's what we call the watchdog. It's a bit of software running a completely different computer that is monitoring what's going on the vessel. Okay. So the main software and the main system is already monitoring what's going on, and if that fails or cannot identify what's wrong, this second level or the second layer of security will detect that there is a failure, and then you probably cut. Normally, the first action is to cut the power to the propellers. Okay. And that's how we protect. And the third level will be the man. The man in the loop will notice that something's wrong, but the vessel itself can take care of itself.
I think along that line, there's another question which is asking about if there is any autonomous collision avoidance equipment installed on board. And there's a suggestion that AIS or ARPA.
Yeah, so we have AIS collision avoidance. We are now developing partnership with the local university, the visual detection, so using cameras to identify targets At the moment, what we can do is using the radar and the AIS to do collision avoidance.
Thank you. I think one final question, squeeze it in before we have to finish off. A question, do you think that the coal regs are ready for mass? Now, I'm kind of lost on this one now, yeah, but if not, what has to be changed in your view?
I don't think completely the coal regs, well, if it depends a little bit. There are some topics in coal regs that mass can simply not do, like providing assistance for a vessel in danger. That's very hard for a USV to do, and it's very, yeah, I don't know how we're going to solve that. I think that's one of the kind of the rules that wasn't thought for robots. It's clearly thought for humans to be there. But in general, if you just consider like navigation and USVs navigating in the same area of other ships and other boats, I think the coal regs are ready. That's the effort that the IMO is doing. So into 2019, IMO issued, well, there was a resolution to spend 2 years studying the topic, and that's why in 2023 you should have the first issue of these regulations. Actually, tomorrow and the day after, there's the annual global conference about maritime regulations of USVs. I'm attending. Well, this year is a virtual event, and I believe, yeah, in the next 2 days I'm gonna have a lot more updates on this topic.
Okay, great. Well, yeah, thanks for clarifying all these questions. I think we should end this webinar.
Sure.
Really would like to thank you, Rafael.
Thank you very much for the invitation, Eric.
To thank you, we offer you the KNVTS membership, free for 1 year. But
thank you.
On top of that, when you do get the chance for this COVID period to come to Amsterdam, naturally you're invited to join for one of our lectures if possible, and we'll meet up.
It'll be nice.
Thank you. I would also like to thank Mariana for connecting us, Mariana Candela, for also arranging all of this. And I should have listened to her a bit more better at the start, so I didn't do the introduction twice. So there's room for growth there. I would like to tell everybody there's a next webinar. So please mark your agenda. February 17th on a Wednesday. It will be on the offshore wind energy transition in the USA, and good chance for all of you to meet Mariana. Thank you very much.
Thank you very much, Eric. Thank you, Mariana, and good evening for everyone.
All right. Good evening.
Bye-bye.